Sir, actually last week Piyush sir said that we have to handwrite the program, sir. He didn't say whether we have to handwrite the explanation also. So should we also do that?
Yes, yes, yes.
Okay, sir.
Okay. Can you see the screen now?
Yes, sir.
With, yeah, okay. So we are going to look at IoT access technologies. And the first IoT access technology we are going to look at is the IEEE 802.15.4. And the reason why this is very popular is because this is specifically designed to work with low cost and low data rate devices. We will see which are some of the most common things. You may not be knowing it as IEEE 802.15.4, but you will find that some other protocols such as Zigbee are more popular, right? You heard of Zigbee, no? I hope some of you may have at least heard of some protocol called a Zigbee protocol. Just let me see a show of hands. How many of you know Zigbee? How many of you have at least heard of Zigbee? Nobody else. Okay. Okay, so there are several protocols for wireless communication between devices. Just like you have your Wi-Fi, you have several other low data rate communication protocols also. And one of which is the Zigbee protocol. And almost we will list out what are the protocols which are based on this IEEE standard. But typically you will find that a large number of these work based on the IEEE 802.15.4 standards. So we will just basically have a look at what is IEEE 802.15.4, and then we will go into how it works and so on. Okay, so these are the major reasons why people prefer IEEE 802.15.4, mainly for wireless personal area networks, and protocols such as Zigbee, etc., are built on this standard. So they share part of it with the protocol, and on top of that they have additional layers built in, which helps them kind of work better. So these are the three main reasons why you will find them being used widely, right? Because they use lesser amount of energy, and the data rates are also smaller. So if you want to transmit small amounts of data, like say for example temperature, pressure, humidity, etc., to the cloud or to somewhere else, device to device communication, if you want to do that also, if you are trying to do device to device communication, Zigbee is a good opportunity, but data rates will be low, so you can transmit smaller data points, not images and videos. Theoretically you can do that, but it will not be a good idea to use Zigbee communication for transmitting things like images and videos. Usually data is what they're looking at. Okay, and this is where you will find most of the deployments. Home automation uses a lot of this. Automotive networks also use this. Industrial grade IIoT devices, and several applications which include wireless controlled toys, etc., etc. In some of the quad rotors, you will find they kind of tend to use Zigbee for small ranges, because security wise built-in systems are there, so it kind of makes more sense for them to deploy that. Some of the 2.4 gigahertz remotes that you are seeing may be working on a Zigbee protocol, or most of them will be working based on 802.15.4. Okay. These are some of the most commonly used protocol stacks that you will find. Zigbee is very popular. Zigbee IP is a variant of Zigbee. Low WPN is another example of this. Not very popular, but it's gaining. Thread is something which is supported by Google, so Thread is also a very popular way in which you will find IoT devices being used. And you have wireless HART and ISA standards. These are for industry and kind of IIoT type applications, industrial IoT type applications, you will find these to be used. We'll go to the next slide. This will give you an understanding of what are the IEEE standards that you have and how they kind of fare as far as the current status is. Okay, so these are all the parent obviously is IEEE 802, and 802 has many standards, as you can see here. You have 1, 3, 11, 15, 16, 18, 21, 22, and 24. So whatever you are seeing, just 1 second, give me a second, I have an important call. Okay, sorry for the trouble, but I have to take that call. Anyway, so you have all the different standards which are being used. So you are very familiar with the 802.11 standard. Ethernet standard is 802.3, and most of what we are seeing now is this 802.15. Okay, and that is where most of the Zigbee consortium and the Y-Sun Alliance and UWB Alliance, all this which are the groups which are kind of pushing for standardization of 802.15. And then there are several other working groups which are working on technology like WiMAX. You may have heard of WiMAX. And then you have the 802.18 standards, which are again something which we are not going to look at. And we are only going to focus on some of the aspects of it. So other things which are blanked out are mostly the things which are not working. This is the current standard as on 2020. Okay, and the reference standard for 802.15.4, the latest version is also 2020. So it has been in existence since 2004 or so. The latest revision that you will find will be in 2020. And this I have taken from one of the working groups presentations, which was authored by Tim Godfrey, and he is one of the big people uh, in this field of standardization. EPRI stands for Electrical Power Research Institute. So he is a major kind of figure in EPRI, based out of Kansas. So if you want to just check out his profile, you can go to LinkedIn and find that. So these people are kind of, there are like 30-40 people who are kind of majorly representing all the working groups. So this presentation though is by Godfrey. So we'll just go to the next slide. I hope this gives you some understanding of what are the different IEEE 802 standards. Can we go ahead?
Yes, sir.
So you will find that 802.11, you will have this standard which is multiple types. So you have A, B, G, N, AH, etc., etc. So some of them are useful for high-speed communication, some for low, and so on and so forth. Similarly, you have 802.15, which is mainly for personal area networks, not for WLAN communications. So in this case, you will find that 802.15.1 is Bluetooth. Similarly, you have .4, which is mainly, you will find that 802.15.4, 3, 6, 11, 15, and then you have 20 also. That is not mentioned here. This I have picked from Cisco, but there is a variation which has come in 20 also. So I suggest that you insert 20 also here, 15, 20. And there what you have is you have the modifications in this particular protocol which has happened over period of time. So you will find that you have a separate standard which has come up for Chinese devices. You have certain increments in 2012 which were for Mac, kind of security and those kind of things. Enhancement was done, and in there's a variation called F 802.15.4 F, which is mainly the physical layer definition for RFID technologies. 2012 there was one more modification which happened for mainly smart utility networks like smart grids and so on. So you have this white space, all those kind of different applications have happened. And then you have the 802.15.6, which is body area networking, which is mainly for wearables. And then you have 15.7, which is for visible light communications. So like you can transmit data in the visible range. So those standards are available here. This is not something that we are going to look at. Mostly it's in the research phase right now. You will not find a lot of commercially available cheap technology which works on this area. We are mainly concerned only about 802.15.4. Okay. And then you have another increment on this, which is 802.22. That is again not something that we are interested in. This is for regional area networks. We are only interested in 802.15.4. This one. Okay. And what exactly is 802.15.4? Many, some of you may be feeling left out as a result of not paying attention and also being too lazy to look up after the class what the terms I am saying is. Okay, means. So if that kind of situation is there, I'll just thought I'll give you from the basic what do you understand by 802.15.4. So basically the idea is the IEEE 802.15.4 mainly looks at the two layers of the OSI 7-layer system. You've heard of the OSI layers. Have you are you familiar now with the OSI model?
Yes, sir.
Anyone of you? Yes. Okay, so what we are looking at is the 802.15.4 typically provides standardization for these two bottommost layers. Okay, and the remaining layers you can kind of add your own stuff, you can customize your own stuff, and you can put more functionality into the system. So all the other commercial protocols that you are seeing, Zigbee, low WPVN, VPN, those things are all based out of 802.15.4, which uses these two layers, and on top of that they continue to build up. So what happens in the physical layer? You will see that in the physical layer, or the PHY layer that you are seeing, will have these things. It will tell you how to encode the data, what kind of requirements are needed. That means basically what kind of transmission technique will be needed. That is also there. What kind of antenna requirements, what kind of frequency you will need, etc., etc. And also you will find the physical medium of transmission. How do you transmit, in what sequence you have to transmit, what type of voltage levels are you using, are you using CMOS level, DTL level, all those things will be mentioned in the physical layer of a system. Here also we do the same thing. And in the data link layer, because these are the two layers that we are talking about when we are talking about 802.15.4. Okay, so here also you will find that in the data link layer, we are only worried about the establishment of the link, transmission. If the transmission has been successful or unsuccessful, that you will get. And then you will check the error if the frame is coming correctly or not. And you will also be able to check if the system is working, if it can access the physical medium, if it is working, not working, and so on and so forth. What the information content in the system is, or what to do with that next, is something which will be handled by the higher layers. So the two bottommost layers are what you will be finding as being standardized in IEEE 802.15.4. So these strategies or whatever techniques are being used will be common across all the protocols that you will see based on 802.15.4. Okay, and the general functionality of data link layer is what I have listed it out here. And what are the main characteristics? This is what you will find as the main characteristics of data link layer. Sorry, main characteristics of 802.15.4. So no matter whatever device, commercially available device you pick up from the market, you will mostly find that it will correspond to all of these things. Okay, you may buy it from Microchip, you may buy it from Texas Instruments, you may buy any device that you have made which can do all these kind of which uses 802.15.4, but all of them will maximum have a data rate of 250 kbps. Output power will be about 1 milliwatts, and you will have about 50 to 60 meters of range. And typically the power consumption, obviously, as you can see, will be very low. And they will all be working in the range of 915 to 2.4 gigahertz. Okay, so 915 megahertz, around 915 megahertz they will be working, or about 2.4 they will be working. All right, so that is the main characteristics of the 802.15.4. So this is one example I thought I will give you. I think this should make more sense to you than just understanding theory. You have heard of PIC microcontrollers? Anyone has heard of something called a PIC microcontroller? Nobody has heard of PIC microcontroller. Hello? Am I audible? Okay, PIC used to be a very popular type of microcontroller before Arduino came in. Okay, because when we were students, we mainly worked with PIC microcontroller. Because you had only two versions which were kind of we were using. One was the 8051 kind of variants of 8051, and then you have the PIC microcontroller, something like 16F877 or 18 series, 16 series, those kind of microcontrollers, and they are all made by Microchip, a company called Microchip. I hope you may have heard of Microchip at least. They make a lot of like the drivers for your motors, and they have a lot of transceivers, etc., etc. You've heard of Microchip as a company?
Yes, sir.
I think it's one of the recruiters in our campus also. So you may have some of your seniors are working for Microchip. Actually, it's one of the biggest chip manufacturers, general purpose chip manufacturers, not like Intel and AMD, but these kind of things they make in big numbers. So Microchip is a big company, and Microchip kind of makes microcontroller boards which are kind of called as PIC. Okay. So it could be replaced by any other board also. Okay. So if you can see the diagram here, you will see that you can kind of replace it with anything, no? Because you have this SDO, SDI, SCK, interrupt. All those things are generic. I mean, like you can have a same thing in Arduino also, na? Right? So there is no SPI interfaces are kind of available for almost all the devices now. Correct? You worked with SPI in Arduino? Any one of you? UART, SPI? How many of you have worked with that?
We had a lab.
So you know what is SPI and you know what is UART, no?
Yes, sir.
Yes, yes. So okay. So basically serial. So you are looking at serial communication, and this is how you can replace this PIC with Arduino also. Works the same way. Connections will remain the same though. So you can see this is one example that we are talking about. This is a chip called MRF24J40. So this is the chip which is made by a company called Microchip, and usually what you will do is you will find not as a single chip but as a board. So like this. You can see my mouse hovering around this. You will see boards like this. Okay, so now what is happening is that the chip will be on the underside mostly, and it will have all these things. This major chip will be there. There will be an oscillator. There will be matching circuit, all put on one single board like this. Okay, and this is the antenna, and there will also be a standard antenna which you can kind of screw onto it. That is being shown here. The matching circuitry is also on the board itself. So this chip is being made by microchip, and you can see here that the system that they are selling is a complete 802.15.4 radio, which basically means that it kind of complies with the 802.15.4 physical and MAC or the data link layer protocols, and it can also support both ZigBee and MyWI protocols. So ZigBee is more common, so you can kind of implement ZigBee protocol on this. Okay, and you can see there are things like you have the automated acknowledgement that comes in, you have security built into it, you have the low current consumption that is common, you have a CSMA-CD, CSMA-CA type mechanism where you kind of check for any collision during the message transmission happening. So all those things are possible, and this is what I wanted to show you. So the whole board, the whole chip that you are seeing here, MRF24J40, will appear to like a single chip itself. But inside the chip, you will have the physical and the MAC two layers, which are common to IEEE 802.15.4, and then you have separate modules for interface, separate module for power management, and separate module for memory. So you have additional layers which can implement all these things in there, but the two layers, physical and MAC layer, will remain the same. And this module you can buy off the shelf. I think should be about 500 or 600 rupees, and you can connect it to your Arduino also. You can see the bottom part is your Arduino, you know. Yes, and this is called the ZigBee shield. What you are seeing is the big board on the top, right? And the ZigBee module is sitting on top of the ZigBee shield here. This is same as this. Shield is something which you have to directly use to connect to this, because otherwise you have a lot of pinout will not be matching with this. So that is another issue, because you can see there are pins on this side and there are pins on this side, and it's just a fraction of size of Arduino. So it will not look very nice when you are connecting, and the leads are all male. So usually people tend to use this kind of a shield and plug it onto the shield and use the pinouts whatever is remaining out just to further program it. All right, does it make more sense now?
Yes, sir.
Yes, okay. So we'll go to the next slide now. And the device types. So if you have seen this, I told you something that in the 802.15.4, you have device to device communication, right? That means you can transfer data from one Arduino with this setup, okay? You have multiple these kind of setups, say 8 or 10 of them, and you can transfer data from one to the other. It will be a kind of a good challenge for you to try it out. If you have multiple such boards, you can transfer data, or you can basically do hopping of data from one board to the other. But the only thing is that you will need one Arduino ZigBee shield and a ZigBee module. And similarly, you can create a network of 10 or 15 or 20 such devices, and you can just hop the data from one to the next. There's no need to connect to the cloud at all. Okay, so that is the advantage that you have with this kind of a system. But if you have that kind of a scenario, you have two cases. You could have either a full function device, or you could have a reduced function device. A full function device, though, can operate in three modes. Okay, you can have it working as a device. You can kind of make it work like a coordinator, or you can make it work like a band coordinator. What do these three things mean? We'll see next. Okay, a coordinator is a full function device that can relay the messages, which means that it can pick the message from some place and it can transfer it to the next node. So when you have that kind of a situation, or that kind of a device which has got its capability, you will have a coordinator type device. So usually what happens is that if the device is not a coordinator, you simply call it a device. And usually the things which can only be called as a device are the ones which are much smaller in cost and much smaller in functionality. So more very cheap devices which can only transmit will usually be called a device, and they will not have a lot of functionality built into them. Okay, and what we have seen in the previous slide, these things you see here, they can work as either coordinators or they can work as the pan coordinator. Okay, so the Arduino module that we saw, any one of them can work as coordinator or as pan coordinators. Why? Because they have the ability to both transmit and receive data, and also at the time coordinate which node can transmit, which node cannot transmit at any given point of time. Because when you are creating a network, there should be some kind of controller which should decide when the data transmission from each node should happen, so that the collision or the clashing of packets can be minimized. Because we are looking at very small data rates, right? So we cannot afford to have a lot of losses. So usually the better idea will be, we can take the latency, but it will be a better option if we can kind of schedule the transmission and reception of data. So that is why you will find the concept of pan coordinator becoming very important. Does it make sense?
Yes,
Hello?
sir.
Can we go to the next slide?
Yes, sir.
So this is what we are looking at when we talk about, we have come across these terms earlier also, if you remember. Multiple times we have come across these terms. So I will repeat this once again. Full function devices are like mobile phones. Like they will fit anywhere, any particular star network and mesh network, whatever node network you want to set up, they will be able to do it because they have sufficient amount of computational power and the communication bandwidth to handle that. Okay. On the other hand, you have the reduced function devices which can only communicate to their main coordinator or to some other central location where full function device exists. RFDs can only communicate to FFDs. They do not have direct connectivity to the cloud. They do not have direct connectivity to each other. Usually RFDs will work with by transmitting information to full function devices. So there will be multiple such smart switches or whatever you may have, and they will all be working, they'll be connected to one single full function device. Okay. And because it is very cheap and very simple, there will be very little small instruction set to configure them. Implementation becomes very easy. But usually it will be like, say, connect it using a serial port or serial communication interface or SPI. Some very simple configuration will be needed, because the protocol stack implemented will be very cheap, very simple, because we want to reduce the cost. So reading the data also becomes easy. Unfortunately, security wise, there will be issues because security will not be a part of most of these devices. Right? You want to get a device for 200 rupees, you cannot have a lot of security built into this. No encryption standards will be there, no security will be there. So, okay, so that you have to be careful about. Okay, and we have already seen this. What is star network? And you can see there is a coordinator which we have. Master slave type connection will be usually happening. Full function devices, and you have the reduced function devices. If you remember, you will have usually the communication will be going like this. A large amount of information will be going from the reduced function devices, RFDs to FFDs, and there will be some very small instructions which will be coming from here to this. Like for example, usually when the polling action happens, polling in the sense when the full function device kind of asks the RFD to send something, only then this communication in this direction will happen. Otherwise, there will be no communication. Only one-way communication will usually happen. And this also, full function devices can connect anyway. And there are some criticisms of 802.15.4, which is on the latency, multipath fading, and the reliability of the MAC process. Have you? There's a lot of noise going on here. Have you kind of worked with the Mac? You know what is Mac? MAC layers?
No,
No.
sir.
Media access control sublayer? No.
No, sir.
Okay, I think it should come as a part of the computer networks. You should be learning that soon, I think.
Sir, you're muted, sir.
No, then I think you may not even have heard of CSMACA. Have you heard
No,
of
sir.
this thing?
No, sir.
Oh. Okay. And you know what is multipath fading?
No, sir.
Okay.
No, sir.
Oh. Okay, so I was under the impression that you will be knowing these things already. Okay. Fine, then I think I may add a few more things to this and then continue with the class. That will be better. Otherwise, you may have difficulty understanding what this is. I had only one slide on this, but I don't think that should be sufficient in this. Okay, anyway, I think I will stop with this now, 12:36. Okay, 4 more minutes to go. But please remember that you can refer to the IEEE standards in this page. 2020 revision, as I said, is the latest revision, but most of it is kind of paid. If you go to IEEE standard page, you will find that you may have to pay for these devices. The login will ask for money because standards are usually on a pay basis. Even for university affiliation logins, they don't give it. It's only for commercial organizations that they usually provide. So, but still there is a lot of material available on the net for the 2020 revision also. So if you check in the internet, you may find some examples of 2020 revision, but otherwise the older revisions and all those things are already available. The ones that are deprecated are also visible to you. So you can see how they have evolved over a period of time. 4, 8, I think 12 was the last one. No, 15 was the last one, I think, and then 20. So how the evolution has happened over a period of time. Okay. So I think that should be sufficient for today. We have 3 more minutes remaining. If you have any questions, please go ahead and ask. Any questions?
No, sir. But only we have want to know about this multi-path fading, but you told we can ask tomorrow.
Again, I did not get that.
Sir, I only had doubt about multi-path fading and all, sir. So can I ask tomorrow after you teach that?
Yes, yes. No issues. Maybe I'll just take it in the class also separately for everybody. I'll
Okay,
just
sir.
give you some idea about CSMA and also multipath fading. What do you mean by that and so on. Yes, maybe in the next class I'll do that for everybody, because that this one single slide has a lot of information content. If you don't know what it is, then it will take a long time to uncompress all the information. So I'll handle all that in the next class. Okay. Yeah. Anything else?
No, sir.
Okay, then I think if there are no further questions, we will break for today. We will continue in the next class. 1 second. Okay. Okay, then I think we are done here. Thank you all for attending. We'll continue in the next class.
Thank you, sir.
Bye.
Thanks.